Welcome to DevOps Accents, a podcast on everything around DevOps, public cloud, and cloud-native topics, with your hosts, Pablo, Leo, and Kirill.
Hello, everyone. Welcome to a new podcast. I don't know, this is the number 17?
Yeah.
Yes, I think it is 17. And this time, as you can hear or see, depends where you are, Leo is not here. It's not because he is dead. He is still alive. Only thing that he is sick. I don't know how many times he has been sick for this year. Maybe it's the time number 25, 26. Leo, we love you. And today it's only Kirill and me.
But not today.
But he's alive, he's still alive. And today we are only Kirill and me. So we are missing the moderator. We are missing the person who tell us what to talk about and all these kind of things. So we are going to be alone. And we are going to try to do our best thing. And because we don't have moderator, we are going to start to talk about what we want to talk. So,
Two lost kids.
so the first thing that we want to talk is because there is a new dispatch, there is a new article that we write. And I think that it's a super interesting topic because it's something that everyone is talking, not these days, long time ago. It's talking about all these climate changes, the pollution, and all these things that are happening in the planet Earth. There are people who believe that this is happening. There are people that believe that this is a cycle of the Earth and that this is every whatever number of years this is happening. That, okay, how can you say that it's not raining because here in my city it's raining? Oh, I check in the weather for the last 30 years and it's always the same temperature. Okay. But in whatever point, we want to talk about that. And our point is not to make something like a politic speech. It's only to talk how the cloud, because the title of the dispatch is called Cloud with CO2, how the cloud computing and how all these tools that we're using today, like WhatsApp, even, Facebook, all these applications seems the most simple that you have in your cell phone because maybe this video game that you're playing every day is using a cloud computing, how this massive amount of cloud computing is generating contamination. And even the problem is that the best thing that could happen to a company is that you spend more and more. And the best thing that could happen to Google Cloud, to Amazon, and check Amazon, how good is these days with the stock market. So the best thing that could happen to all these, all these companies is that they're selling more and more. And sell means more contamination. So the idea is, what can we do to stop that? Or what can we do to improve that? Because we are in a point that we cannot say today, no, we are not going to use anymore the cloud, because I think that there is no way back these days. There is no, I don't know, Kirill, what do you think?
No way back for sure. But okay, I have pointed the CO2 part in the cloud because what I noticed AWS added the CO2 reports since like a couple of years now. So if you go to your AWS console for the main account, for the management account, there's a page where you can see emissions, and then it shows you the graph, which basically if you're working in the EU central region, it always tells you, yeah, maybe 5 years ago it was bad, but now it's like zero, so you don't generate any CO2. And I think honestly, from this perspective, it's having this kind of reports is just the box ticking. I had a customer, and they basically were obliged to kind of provide some kind of report on the CO2 emissions. And then, it's like, hey, how can we calculate it? Can we use some open source tool? And then, well, Amazon has it. You just go and then you download this report and then ticked the box that your cloud CO2 emissions are zero. And because in that, there is no way you can verify these things end to end, right? So Amazon will tell you, yeah, our CO2 emissions are zero, but then you think, okay, what does it actually mean? Does it mean that there are like solar panels on top of the whole data center? Or you buy energy from some renewable energy provider in this particular country?
Yeah.
Or you actually just burn gasoline to power your data center, but then you have some very good filtration system, whatever, to make sure emissions are not there. So you don't know, right? We have like how many, 50 regions by now, so it really depends on how they work. From users of cloud provider, I think it's good if you want to just add on your web pages like, yes, my infrastructure is CO2 neutral, but there is nothing you can do, right? It's like with your own data center, you can do some CO2 reduction because you have a direct influence. Like one of our shared customer in the past, they have the data center here in Munich, and they can optimize it to be CO2 neutral. But if you're using the cloud, what can you do? Amazon can tell you, yeah, actually your infrastructure reduces the Amazon forest by 2 square kilometers every day, plus is the same number of CO2 emissions as 1 million cars. And okay, actually, well, you can't do anything about this. It's there. You don't have a control because you don't manage data center. There's this shared responsibility model where the hardware, hypervisors and everything is managed by Amazon. And yeah, you can migrate from Kubernetes to Lambda or vice versa, but it doesn't change anything in the CO2 emissions.
Because to prepare this article, I was reading, I was reading that the 1% of the current emission in 2020, I have no idea, to 2021, 2022, 2023, or even so on. So the 1% of all the CO2 emissions that are happening in the planet Earth are because data centers. So you can say it's only 1%. And it's a low number, but if you think it's something that is growing and growing and growing, and really, day by day, everything. Because I remember many years ago when the people was telling, the cloud. No, this is something that happened. Now, every organization has something in the cloud. And you can see the numbers with AWS, every quarter report. So they're always growing. So AWS, Azure, Microsoft with Azure, so AWS, Amazon, and Google, and all of them. So all of them are growing and growing and growing. So that means that day by day, they are going to be also, consuming more and more. So, and there is something too that for me is important to understand. It's true that it's important to consider that, but we don't need to put all the pressure on the person who consumes, no? Because at the end it's the same thing that when you buy a flight ticket, no? And they're telling to you, there are companies like Lufthansa.
Don't fly.
Sorry?
They tell you don't fly. No, because there is this thing that like you should not fly. Like I think, did you tell me that in Spain, I think in France, there are no flights inside the country anymore? That the trains are so good, so you can get like from Barcelona to Madrid so fast that there is no sense in having an airplane doing this.
But it's full of airplanes everywhere. Spain to Spain, eh?
Okay. But then I think it was France. One of the EU countries recently, they changed that there are no more flights between cities inside the country because it became pointless. And plus whatever emissions.
No. Here is full of airplanes, city to city. And even imagine myself, I live in Canarias.
Of course, there is like no train from Madrid to Africa. Yeah, I understand that. But probably the train Madrid to Barcelona makes not that much sense today, right? It's just financially and for emissions wise, and actually how much time you spend on commute, there is no reason to fly this way. The train is just way better.
Completely agree. But at the end, is the idea of depends of the situation, it depends of the price, depends of the moment, depends where you are living. I understand, but only tell to a company, an airplane company, you cannot put an airplane from Madrid to Barcelona. I think that even this could be against the European laws because you are telling you cannot grow as a company. And this is the problem because what I wanted to say before is they are telling to you, for example, hey, you take this airplane, it's going to be 300, I don't know, the amount of CO2. I tell him to 300, maybe it's stupid what I tell him. It's like when you go to Google Flight. And it seems that the guilty person is the one who is buying the ticket.
Yeah.
So they split the guiltiness between all the buyers. And I know that there are people who is suffering for that. And the same thing could happen when I'm going to say sysadmin or an infra guy or a DevOps is executing a pull request. Because as soon as you execute git push, everything starts to work and you're consuming and you're spending and you are generating CO2 and maybe a little bird is going to die because of your git push. So And it's not like that. Okay, it's like that, but it's not like that. It's not like there is a cause and effect. So it's not like I click the button and then the bird that is flying.
Yeah.
But this is something interesting too, because it's important to understand that.
For me, it's crazy. And I think like this topic is like, it's always 1 nanometer away from getting political.
Yes.
Because it's impossible. Like it, as long as you start on like, you can say, yeah, don't fly, like take a train. Okay, let's look at the case in Germany. The train Munich to Hamburg is 750 kilometers, something like this.
Yeah.
If there would be a train that would take me 2 hours, and it's not against the laws of physics, there are trains that go with the speed that takes me in 2 hours Munich to Hamburg, I would take the train. Yes, I would be completely CO2 like negative, etc. But there is no such train. The train takes 8 hours for this distance, and this train also has a tendency to break, so it can take me 12 hours. And if I fly by train, if I fly by plane,
Imagine Harry Potter.
there was this Jim Button book, and I think they had some kind of a flying train, right? No, and if I take the plane, Munich Hamburg, it's 1 hour 15 minutes. And then, yes, there are people who feel guilty for taking the plane, but I have personally zero guilt because I am not building the trains. It's like I can basically, the only reason I can influence is by voting and paying my taxes. But that's it. In the end of the day, I want to have my 10 hours of my life back. And I don't want to spend them on a train that is probably like halfway broken. There is no internet. Because I'm a very limited amount of time on this planet. So I feel always zero guilt for taking the plane if it makes sense for me personally. Munich, Berlin, for example, the train is like 4 hours, 30 minutes for 600 kilometers. For sure, like we discussed it the other day in private that it's like going from Madrid to Barcelona. There should be a way better trains than there is. But with 4 hours, it's actually comparable because then with the airplane all and door to door, it would take me like 3 hours because I need to get to the Munich airport, which is like in another country almost distance wise. And then it's 3 hours against 4 hours, but 4 hours in the train I can actually work, and then it makes sense. And then I think it should be like this for most people. Like, yes, you should not forbid company in Spain to have a flight Madrid-Barcelona, but train is just so much more attractive that I have to imagine majority of people would pick the train only because it's just a better value for money and you get there faster.
Yeah, there is, even these days, there is a new number of companies that are introducing more trains, but you need to think that in the capacity, because at the end the problem with the trains is that there is a line. So in the air you can put 20 airplanes and you can put in parallel. Yeah. And they can fly at the same time. The problem with the train is that there is a maximum amount of trains because of the speed, because of the tracks that you can put direction point A to point B. So, and this limit is the main topic because the amount of people that they need to fly from the 2 main capitals in 45 million, so 49 million country, maybe is 200,000 per day. I cannot, but it's a huge number. So at the end, you need cars, you need bus, you need train, you need airplane. So, and even for me, I live in an island, so I cannot feel guilty because I take an airplane because the way to go from my lost island in the middle of Africa to Spain is with a ship. It's taking 5 days, 4 or 5 days. And I don't want to spend 5 days in a ship. And even the train is spending CO2 because it's not, everything at the end is contaminating the planet. But okay, backing again to the application, backing again to the data center, I think that is very important, this point, because we need to try to fix that. And this is, for example, is one of the reasons, because as less the company spend, it's going to be better for them first economically, and it's going to be better for them in this ecologically way too, because at the end, as less they're spending, and we have a very good audits in cost reduction for the cloud. So as less they spend, it's going to be much, much better. But we have the enemy on top. And the enemy on top is the same guy who is giving to you the tools to use. In this case, is the cloud companies, whatever cloud company, because as much money you spend in the cloud, they are going to be more happy. The stock owners are going to be more happy, and everyone is going to be happy. So then they are giving to you nice tools to see how much CO2 you spend, but at the same time, they are telling to the third-party vendors, whatever provider, to everyone is telling, you need to make that this customer spend more. And you need to do the test with huge machines. And if you can use GPU, use huge amount of GPUs. So do everything that you can do because I want you to spend billions. So at the end, it's something like a magic trick, no? So take care.
But the good thing, just in case of AWS, I'm not sure if Google is already doing this. Okay, first of all, every cloud is elastic, right? So you can basically adjust how many resources you have based on the time of the day, based on the load. So then I don't know, like if it's correct, say it's like your carbon footprint, if that's applicable here. I don't think actually it makes real difference because in the end, the server on Amazon site is already there. But let's say if you use less compute resources in AWS, then somehow carbon footprint of the data center also goes down. And every cloud is like this. So you can basically not run any workloads at night or on the weekend in your different staging, and then it goes down. The second thing is that what Amazon is doing since, I don't know, like 3-4 years, they create their own processors. So like Apple has this Apple Silicon for consumer computers. Amazon has these Graviton processors, which are IRM chips. And these IRM chips, what's good about them, they're cheaper. They're faster for many, if not most, workloads, but they also consume way less energy. So kind of AWS replaces slowly everything with the Graviton processors, which is really good. It's really good for them because they control the production and they reduce their costs because it's their own chips. They don't need to buy anything from Intel long term. Probably they need to do it for another 20 years, but it's the same direction Apple is going. Just for Apple, it's probably easier than for AWS. And then you as a customer also win because you get something better for less money, and humanity wins because it consumes less energy. Because the problem is in case of data center is electricity, you have to imagine. Yes, there are these generators with diesel that kind of, in case there is like power grid outage, but in general, data center is connected to the electrical grid. And then the question is, where does the electrical grid get electricity from?
Yeah. But the main point is that I was thinking now, because I remember the numbers, internet today, the amount of info that we have in internet today is 100 petabytes. And we need to understand that a petabyte is the mega, the giga, the tera, the peta, the exa, and then goes the theta. So, and if you compare the amount of petabytes that it was something like 5 years ago, 10 years ago, with the amount that we have today so what I mean is that this is not going to stop. So at the end, as you can reduce the computing, but at the end, you can reduce everything, but there will be a fight because I think that the best way to see that is something that we can, again, I don't know if we can see that, is the power invoices for these companies. How much do they spend in power? Because this is the big number.
There are no challenges that we couldn't overcome. Whether it is immediate infrastructure problems or planning a future project, we won't simply answer your questions. We become a part of your team to help you complete the mission. Our solutions consider the interests of your business and the combined expertise of the industry, as our staff is made up of more than a dozen experts in different areas who share decades of field-tested experience and knowledge with you.
Changing the subject, Kirill, we were talking the other day, and you were telling that you were working with something new in AWS with Lambdas. Could you explain that, please? Because you were explaining something, and it was super interesting.
It's not entirely new. I was just involved in the last couple of weeks in a project that had a lot to do with optimizing Lambda functions. Mm-hmm. And because like in previous couple of years, I was primarily focused on Kubernetes and optimizing Kubernetes clusters and building some stuff of Kubernetes. But now again, like I was deeply involved with Lambda functions. And what I realized once again is that it's really easy to start with, what is Lambda? Okay, so it's really truly serverless offering from AWS because now there really is lots of things they call serverless, but then it costs minimum 1K per month, even if you don't use it. So not really serverless. But Lambda is serverless because you have inputs, your code is executed, and you pay per millisecond of execution time. And when your code is finished, you pay nothing. And then it's really easy to scale out because, if you have one event, there's only one Lambda execution. If you have suddenly 10 million events, it's okay for Lambda because it just transparently processes all of these events and you don't need to think about it, which is super cool. And it's something that exists since like almost 10 years now. It's nothing new, but it doesn't make it less cool because it's also one of the most widely used serverless function services. And it's crazy how good it works and how much it scales. But what I realized is there are some really tricky things about optimizing Lambda because, first of all, when you execute Lambda function, it's not like there is still some server behind it, right? And the way it works is that when you first execute Lambda function, there is this cold start because AWS needs to like create a micro VM. I think they use Firecracker, I think, even though I'm confused like how the hell it's so fast because Firecracker is fast, but it's not as fast as Lambda. But okay, let's say they create a Firecracker micro VM. And then this micro VM exists for a bit longer than your code is being executed. So if you have 3 events incoming, then they will be processed by the same micro VM. So somewhere inside AWS data center, there is still a server that processes your requests more or less. Of course, it's more complicated by this, but not every Lambda function execution is completely isolated from each other. They need to worm it out somehow. The problem comes when you create, as I said, like 10 million executions at the same time, because when you have such a huge spike, and let's say it takes maybe like 5 seconds for each Lambda execution to be processed, then a single micro VM cannot process 10 million requests at the same time. It's still busy processing the previous execution. So what AWS does, it creates another Lambda, and another micro VM, and then another one just to handle this load. And it created still the quota limit you have by default, which is 1,000 concurrent executions per region. You can increase it to tens of thousands per AWS, but by default it's 1,000. So which means if you have lots of different Lambda functions, one of the Lambda functions gets like 10 million requests, it can basically consume this whole concurrency limit that you have, and all the Lambdas in your AWS account in the region gets throttled because they would say like, yeah, there is not enough concurrency available because for other Lambda, there is basically no space to create this micro VM to process requests, which is a problem. And that's, I think, one of this, like when you reach a certain scale, that's when you realize, okay, actually Lambda is magical, but it's not entirely magical. There are still micro VMs, there is still concurrency. You still need to understand how the flow is looking like with this init phase, the code execution phase, and this warming up stuff. So then one issue is this limit, which, as I said, like you can increase. You can say, AWS, please let me run like 20,000 concurrent Lambdas at the same time to handle this kind of spikes. But no matter how high is the limit, you still have the issue with the noisy neighbors, let's say, because imagine you have 500 Lambdas in your applications, and then one of them consumes all the limit, and then some really critical Lambda function gets throttled. So to handle this, Amazon has a feature called reserved concurrency, where you basically say, please reserve for this Lambda function 50 of concurrency. So then AWS guarantees that it will not be throttled. There are always 50 executions available just for this Lambda.
Yeah.
Now the problem is that these 50 are consumed from this pool of max concurrent executions per region. So you have 1,000 by default. You reserve, let's say, 100 for particular Lambda, which means for all the other Lambda.
So you had 900.
Yes, for all the other Lambdas, you have only 900 now. And this is somehow like you think, okay, now I'm entering this stage where I'm actually doing some kind of capacity management for Lambdas because I need to look at the metrics. There is a metric for concurrency, how many concurrent executions are happening. And you see, okay, this Lambda usually consumes like 20 maximum, so I need to reserve 20 for this and then 50 for this, and then you basically allocate reserve concurrency for every Lambda function you have to make sure that none of them is getting throttled. Which is kind of, like this Kubernetes, when you think something magical is happening for you, but in the end, the physical reality hits you and you need to manage these kind of things.
Yeah.
And then there is something else. There are cold starts, as I said. So the Lambda function is basically when you don't execute it, it doesn't exist. There is no micro VM. First time you execute it, there is some warm-up time, which is especially annoying when you use Lambda behind some HTTP synchronous API gateway. You don't want to have like this cold starts. So then there's another feature in Lambda called provisioned capacity concurrency. I forgot the word. Yeah, provisioned concurrency, which says at any given time, please keep one micro VM for me, so that there is no cold start. So AWS kind of warms up your Lambda function, does this initialization phase, and then in the end there is a micro VM always listening. Can you pay for this time when it's provisioned? You don't pay the same amount of money as you would pay for the execution of the code, so it's still like super cheap. But now you basically have to think, oh well, my serverless function actually needs to be a bit less serverless and exist all the time because I execute this Lambda function behind API trigger from the browser, and then my front end will have this cold starts. So you need to make sure that there is this pre-warmed up Lambdas during some times of the day. And that's another thing you need to handle. Then even more interesting part is the Lambda resources, because in Lambda you configure how much memory is allocated to the Lambda function, and you pay per gigabyte per millisecond. So let's say if you allocate 1 gigabyte of memory to a Lambda, you pay, let's say, $2 per millisecond. If you allocate 500 megabytes, $1. Of course, it's not $2, it's like 0 point and then 0.0000, like 1 millionth of a cent. But performance of your Lambda function depends also on compute power, which you never configure. And it happens kind of, it's invisible to you. You say like, I need 3 gigabytes of RAM. And then AWS is like, okay, for 3 gigabytes of RAM, internally we allocate this number of CPU resources. So, maybe you don't need so much RAM, but you need to have this powerful computation capacity. So you have to over-provision on the RAM.
Yeah.
And you don't really know what the performance of your Lambda function will be. So you need to kind of experiment. There is, for example, this AWS Lambda power tuning, which is an open source tool that executes your Lambda functions with different configurations and gives you a visual, like a graph telling like, okay, with 3 gigabytes of RAM, it will take 1 second to process request. And then with 1 gigabyte of RAM, it will take 4 seconds. And then you calculate like, okay, 4 seconds x 1 gigabyte is actually more expensive than 1 second x 3 gigabyte. So I will use this configuration, which is, once again, serverless, but you need to think about these kind of things like memory and RAM once again and calculate them properly.
Because at the end, the physical part, as you said before, is there. And when you execute one Lambda or one cloud function, with one it's something like magical, no? It's something like the Harry Potter is using this word.
Yeah, they're like, you never see any server. It's just like, I just execute the code and I pay it per millisecond.
Yes.
Per millisecond of gigabyte of RAM. But once you move to production, to real case scenarios, you hit this kind of limitations.
Yes, and
there are many things.
Sorry, you discovered that Harry Potter is not there. It's a physical.
Yeah, that it's just an abstraction on top of micro VMs running on top of probably bigger VMs. I don't think it runs on bare metal, which runs on the bare metal machines in AWS data center, which is powered by electricity grid, which is powered by who knows what, gas, coal, like now in Germany, atomic energy, etc. So physical world is still there. And there are many things like this in Lambda. Like, I don't want to spend all of our time on this. I just one more example. So I want to provide is SQS. So one of the event triggers for Lambda could be an SQS queue. So as long as there is so SQS is the simple queue service, it contains messages and you can process messages with Lambda.
Mm-hmm.
So as long as there is a new message in SQS, Lambda functions automatically take this message and processes it. So what happens if you have suddenly, imagine for your Lambda function, you set reserved concurrency 20, meaning beyond 20 executions, it will be throttled. So the way AWS Lambda SQS integration worked till 2023 is that if you have suddenly 1 million messages in SQS, Lambda service, not Lambda function, but Lambda service, because there is some glue code between your Lambda function and SQS, which is like this handle Lambda control plane. It pulls lots of messages. There are 20 concurrent executions, and then your Lambda function gets throttled, but the Lambda service keeps pulling messages. And then there is nothing to process these messages, so they end up like they return to the queue. They won't be lost, but they get returned to the queue, or they will be sent to dead letter queue.
Yeah.
And then you have like 1 million messages in the letter queue, and then you need to redrive or do something else with them. Why? Because that's how it's implemented. And in 2023, what AWS did, they released something called max concurrency for SQS Lambda. So in addition to max concurrency, provision concurrency for, sorry, not provision, but the reserved concurrency for a Lambda function, you also set max concurrency for this SQS queue. And the way it works is, it's how it should work. You said max concurrency for SQS is 30, so it takes 30 messages and it does not try to pull more.
Okay.
So there is no throttling and there is no failed message processing, which is like, but how come it's only 2023 that it's been released? and I was discussing with one of the senior engineers from one of our customers that basically you cannot just use this reserved concurrency for SQS max concurrency because Lambda function can be triggered in many ways. So you cannot just say use this 20 for SQS because there could be 5 queues attached to a single Lambda. It could be like 2 queues, Kinesis stream, DynamoDB stream, SN, etc. So it's great. Like I was just thinking a lot about this in the last 2 weeks because I had to optimize a lot of this in terms of how many gigabytes of memory in the reserved concurrency, etc. And it's like, yeah, once you get closer to production, once your application grows, it gets quite tricky. And the gigabyte thing is important because if you over provision gigabytes for a Lambda function, you overpay.
Yeah.
Maybe you don't pay crazy amount of money like with Kubernetes nodes or with whatever RDS, but still you pay more than you should because you over provisioned something serverless. Instead of paying only for megabytes of memory that your Lambda used, you always pay for how much you provision for the Lambda function.
No, but this is what you said, because at the end, if you execute one Lambda, it's not a problem, but if you need to execute 1 million of Lambdas in 1 month, and you over provision for 4 gigs when you need to have only 2 gigs. And as you were telling, because in Google it's the same, the CPUs is compound, is joined with the memory. So you cannot tell, I want to have 256 gigs, but only 1 CPU. And they're going to tell you, no, sorry, this is a joint venture, because at the end, the way that they have is in the hardware, the CPUs are connected with the slot of the memory. So all go back. So you cannot separate that. But it's true because, for example, in Google Cloud, in Cloud Function, the maximum concurrency is 1,000. But at the end, it's the same problem everywhere because, what happens if you have a huge environment and then maybe it's not better. So it's better to have something different to these Lambdas because, this is not working for you if you are a monster, because imagine something like Netflix, that they need to have millions and millions of users at the same time. They need to think something different and how to work with that. The last point that we are going to talk today, less or maybe no, because we still have time because we need to end today a bit early because we have something else to do. The last point is what we are going to do, is we're talking these days, what we are going to plan to do for the third quarter. The fourth quarter, sorry for that, of 2024 is third economical, fourth quarter to 2023. And what our expectation as NKDev, what our plans, what we want to do, what we want to do, what are the plans, because one of our plans is, as maybe we're going to be in London in the DevOps Days in London. This is one of our plans. We are going to be traveling to Barcelona too. We're going to be traveling to Berlin, and maybe maybe it's another other trip. So the idea is to talk here how difficult, how easy it is for a company like NKDev, a company that is growing day by day, because we are getting more and more customers, and day by day we are bigger and bigger. So how easy or how complicated? I think it's complicated more than easy to try to do all these kind of trips, at least for Kirill and me, because we are living in different cities, but okay, we talk each other sometimes more than we wanted to talk. We are sometimes like a old marriage, these 80-old years guys that are living in a house and they're never leaving the house, and they are you're very bad, you're a bad person, I hate you. But okay, at the end I love this guy, but okay. So, but the idea is to explain how difficult could be, to be in one place and another, and to meet a customer and to try to get another customer and to try to meet another person, and to know, because when you are in a company of, imagine, 100 people, 1,000 people, everything is compartmented. You have a guy who's going to go to trip. You have a guy who's going to call the customers. You have a guy, when I say guy, it's guy, lady, or whatever, don't feel bad. But okay, in whatever case, checking the audience, I think that 99% of the people who hear us are male, no women. But okay, hello to the woman that is hearing to us. we want to know about you. So
one of our mothers.
Yes, maybe it's my. No, I don't think that is my mother. Maybe it's just kidding. We never know. But okay, there is a woman hearing us every week. We love you. So and then is when you're in this kind of company that you need to do many things. Even we have a lawyer here because he was this week. He was working like a lawyer. So it's complicated. What do you think, Kirill, about that? What is your point?
I think it is complicated. It's complicated in two ways. Because okay, as a DevOps guys, because still, right, like both you and I, we are pretty much hands-on, and we still are involved technically as technical experts in all the projects. So, and there are always lots of things to learn in this space. Like what I was just telling, like in case of Lambda, even if I know Lambda pretty well, if I did not work with this 1 year, I need to get up to speed with because Amazon releases like 200 new features per day. And then on top of this, as a business owner, as co-founders, we have to day-to-day learn many things about non-technical stuff, like legal and law, and do the contract stuff, and then find out how you should automate signatures, collecting signatures for the contracts, and then how to do conferences, and like this billion things that you always have to basically find the balance, right? Because in my case, I'm still passionate about technology. I still want to know what's happening. I still want to be as good as possible in this expertise of mine, which is technical. But then I need to sacrifice some percentage of this to do things that are non-technical at all, and things that I will never be really good at. Because I will never be a good lawyer. Let's admit it. Not in Germany. Like I lost this race just by being born in another country.
So maybe here you can be a good lawyer. You never know.
Yes, but then I have to probably like quit MKDF and everything else and refocus for the next 15 years and learn German on the lawyer level. Because right now my German is like immigrant developer level probably still
with passport.
Yeah, well, which difference does it make, especially with the upcoming changes in Germany in terms of language tests?
No, but it's true, and it's difficult because every one of us loves to do something, and you need to do what you love plus something that you don't love, and this is happening always, because. You need to be technical, but you need to make interviews, but you need to go with customers. For example, this is something that I like, but you need to have a dinner, but you need to make a trip, but you need to, and then this kind of thing that I said that for the people that they want to be, for example, an entrepreneur and they want to start a company, it's something cool, but sometimes there are many things that are not cool. And it's tired and take more hours than what you can imagine, really, because it's not a full time, it's a double full time job, and it's tired.
At least, and I think one of the things for me personally is that you have to give up a lot of your deep work time, because actually, like, I'll have a fantastic segue to what you've been working on, Pablo, recently.
Why?
Because wait for this. Because for me, what I really enjoy is to be able to focus on really deep work when I'm doing science for 3-4 hours. Like writing an article. If you see, I did not write that many articles in the last 2 years for MKDev, because writing a good technical article takes forever. Working on a video, working on a script is a 5-6 hours of really deep work, doing experiments, reading, writing. And as an entrepreneur, especially at the early stages, you have quite a decreased amount of deep work because you just have to do everything. You would start writing a script, and then in 30 minutes, like, we have this meeting, we have this interview, we need to fix this contract, we need to approve the content, we need to do some changes for another piece of content we did for the customer. It's like there are many things that you have to do, and because of this, it's really hard to find an uninterrupted block of time for a particular thing for the company. I'm not talking about working for the customer, because for customers, for sure, like, it's, I think we must have time, and we do find time. But this MKDev related work is very fractured in time. And the reason I was telling it's a good segue to what you've been working on is because Pablo was working on a new webinar about what is it about, Pablo? Can you tell us about it?
The webinar is about how you can connect a Cloud Run. Okay, I'm going to say public or private, because Cloud Run is always a public Cloud Run, connected with an SQL private and an SQL public. And you can say this is simple, but okay, in Cloud SQL, in Google Cloud Storage is super complex, because when you do with the private Cloud SQL, you need to use 2 components, a VPC, a serverless connector, and then from the other side, in the side of the database, you need to use a VPC peering with a range that is connected for the peering. And what Kirill is telling that is, I'm preparing this webinar for I don't know how long. Maybe months. But the problem is that I never had time, but this morning what I made is I wake up 6 o'clock in the morning. I put my alarm because I say I had to record the podcast today. I need to do things with a new customer. I had to do many things, and I'm not going to have time. So, but this is the problem. I wake up super early, and at the end, when I recorded the webinar, I said, I had to tell to Kirill, because he's pushing me with this webinar for months. And it's not weeks, it's months.
But was the same with my webinar. So we have a webinar about AWS load balancer controller for Kubernetes.
Yeah.
It's like 45 minutes long. And really it took me up to like 6 months to get to the stage that it's published. And not because it takes lots of time to record 45 minutes. It's just still the preparation and finding this block of time. Because imagine, we are making videos every week, right? So every week we release a new video on our amazing YouTube channel. So then fitting a webinar into it is pretty hard. But from my side, it's also something that I enjoy doing, this kind of content, and putting it out to the world is amazing.
Sorry to interrupt, but the problem with the webinar is that there is no cut. So you need to speak 45 minutes with no cuts. And you said, okay, you made a podcast, you're speaking 2 hours, 1 hour every day. No, but it's different, because you need to prepare a video that the people follow with a flow, to don't say, I'm going to leave this thing because it's super bored, and then it's difficult, and you cannot make a mistake.
And it's educational.
Yes, and even that educational, and not make a mistake. So what I had to prepare is the exercises, repeat it several times, repeat until the webinar is okay. So, I was thinking at the beginning when I started, stupid thing, webinar. I can do that in 2 days. But okay, no, it was not true, Pablo. It took me months. But it's there. And maybe we'll be releasing, okay, it's there. I need to edit the video. I will do this evening. But okay, I will send to Leo, to Alex this, and we can release in next week, or in 2 weeks, whatever time is okay.
It's going to be all over our social networks and Dispatch.
Yes.
Our bi-weekly newsletter.
Yeah, we miss you, Leon, because this is your time. Now is when you need to tell. Please subscribe to our channels. We are in...
Sorry, no, we just we just spent like 10 minutes bitching about how much we work without Leo. And now we also have to moderate the podcast
Man,
ourselves.
what else?
Leo,
What is
please.
the next thing, Leo? Come on.
One last announcement, because I forgot to talk about it at the start, because you said that we are doing this cloud cost audits
Yeah.
for our customers. Recently, we published a case study about how we performed such an audit for one of our customers, Kiwi.
Yeah.
So Kiwi is the company that is making digital lock solution for housing in Germany. It's a kind of market leader in building this digital lock that residents can unlock with the smartphone, with the transponder, and offer like the whole solution for the housing companies. And we did a cloud cost audit for them and collaborated with them to publish the results of this. Not all the results, but how much we saved and what exactly we found. So it's published on our website, and it will, at the moment when you are listening to it will be also probably in MKDev Dispatch and all our social networks. And we always try to make these case studies useful and interesting, not just to be promotional material. So I highly recommend reading this, even though for sure we are biased here, recommending anything we publish.
So thank you for listening us. Really, it was a pleasure. I'm going to put radio voice now to say bye. So it was a pleasure to be with all of you. We miss you a lot, Leo. Maybe next time you will be here, I hope. Don't forget to watch our YouTube videos. Don't forget to read our dispatch, and enjoy that we are in summer. See you next time.
Adios.
The cloud tech industry is evolving so fast. Do you keep up with it by improving your skills or upskilling your team? At MKDev, we offer a variety of workshops for just that, from the basics to expert knowledge. Before delivering our workshops and training sessions, we carry out a detailed assessment of each participant. To make sure the workshop is helpful for you and your team, we will add more content to it or throw out what you already know. Or we create a custom workshop specifically for the needs of your team and the specifics of your project.